Alrighty, y'all. So this 9.5 is properties of logarithmic functions. And y'all, these the properties of the logs, they sort of mirror the properties of exponents, and we'll look at those exponent properties when we do the support. Um, but let's get started on our properties of logarithms. All right, so the first property is the product rule of logs. So the product rule says if I got a product, like the log A, M times N, so I got a product being multiplied, I can rewrite that as a sum of the logs. So that would be a log A, M plus a log A of N. So we sort of distribute the log to each of the factors and rewrite it as a sum. So when you're playing with these problems, the examples are going to say express as a sum. So we'll start with a product and rewrite it as a sum. The second property is the power rule of logs. And this is a big one that helps us solve equations tomorrow. But this power rule says if I got a log base A of m to the p, I can rewrite this as a product by bringing the p down and rewriting it as p times the log a m. Okay, so anytime we got an exponent up there, we can bring it down to the front and rewrite it as a product. And that power rule is big. It helps us solve for variables when they're exponents, okay? And we'll see that tomorrow. All right, the next one is the quotient rule of logs. So this is what I do if I got division going on. So I got a log base A, M divided by N. And these sort of follow exponent rules. Like when you're multiplying variables, you add the exponents. When you got a exponent raised to an exponent, you multiply the exponents. And then when you got division going on, you subtract the exponents. So this would be the log A of the M minus log A of N. It's always the top minus the bottom on these. So these would say something like rewrite as a difference of logarithms, okay? And when you were dividing variables, you subtracted the exponents. So this sort of mirrors that, okay? Now, the fourth one we seen yesterday, this is the log of a power. Whoops, log of a base to a power. Log of a base to a power. And we seen this one, log base A of A to the X. Yesterday we said if the base matched the base raised to an exponent, then the answer was that exponent. Okay, so we sort of played with them yesterday when y'all was doing the log stuff in 9.4. So those are our properties. And these properties will sort of guide us through doing these problems today. So first off, they're going to start giving me two problems doing the product rule, two problems doing the power rule. and then 2 problems doing the quotient rule. So the first examples, they'll say express as a sum of logarithms. Well, the only rule that had anything about being added was my product rule of logs, okay? So they're going to give me a product, and I'm going to rewrite it as a sum. So y'all, for number 1, they give me log base 11 of 11 times 121. Now, they don't want me to evaluate it. They just want me to rewrite it using my product rule. So you distribute the log base 11 to both factors. So you get a log base 11 of 11 plus a log base 11 of 121. So y'all, it's rewritten as a sum of logs like they wanted. So final answer. Y'all, this is just getting you ready for my equations tomorrow, okay? So now we're doing it with the ln. ln of d times f. So on these, usually they'll give you one doing logs and one doing natural logs, okay? So the same thing, I'm just going to distribute the ln to both factors and rewrite it as a sum. So I get a ln of d plus ln of f. Y'all just remember, those are small l's and small n's, okay? That's not an I on those. All right, next they want me to express as a product. So since they want me to express as a product, we're going to be doing the power rule of logs. Okay, we bring down the exponent and rewrite it as a product. So on number 3, I got a log base c of x to the 9th. Now, y'all, so what we got to do is bring this exponent down to the front, and this will be 9 times log base c of x. Okay, so that's all there is. So when we're doing logs and simplifying, if we do have exponents on that variable like this, we will bring them down to the front and write it as a product. All right, now number 4 is a little trickier. ln of a cube root of 10. Now, yesterday I showed y'all about these radicals, remember? I showed y'all how to translate a radical into a fractional exponent. Remember, since the a didn't have an exponent by it, we would treat it like a 1. And to convert from the radical, this would become a to the 1 over n. Okay, so the exponent on the variable goes to the top. The index of the radical goes to the bottom. So y'all, that's the first thing we got to do here. So bring down that ln. And this will be 10. Remember, it don't have an exponent by it, so we'll treat it like a 1. So that this gives me ln of 10 to the 1/3. So we haven't done this as a product yet. All we did was turn the radical into a fractional exponent. Now that I got an exponent, I'm going to bring that down to the front and rewrite it as a product. 1/3 times the ln of 10. Hey y'all, so these aren't bad. It's just playing with them and using the right rule to do what they want. So these ones will say express as a difference of logarithms. So a difference, they're looking at this quotient rule. They're going to give me a quotient. and I'll rewrite it as a difference. So 5, I got log base B of a capital B over 3. Now, y'all, you got to remember, MathLab is picky about lowercase and uppercase, okay? So distribute the log B to both of the terms here and rewrite it as subtraction. So that'll be a log base B of a capital B minus log base B of a 3. And y'all, guess what? They're going to do one with the LNs. They're just getting you used to this LN, okay? So the natural log of V divided by T. Oh, you also distribute the natural log to the top and bottom, rewrite it as subtraction, just like we did here. I would get an ln of V minus ln of T. So, y'all, that's using those properties, but now what they're going to do, they're going to give us problems, and we got to figure out, are we doing the power rule? Are we doing the product rule, quotient rule, or whatever, okay? So you just sort of got to remember these properties. So, y'all, here we go. Rewrite as sums or differences of logs. So they're not telling me, but they're telling me that I'm going to rewrite it as either sums or differences on this one, okay? So they're giving me a log base D of x to the 4th times y to the 8th times z. So y'all, I'm just going to play with y'all a little bit. On this problem, do y'all think I'll be using the product rule or the quotient rule? So what I'm saying is, will I rewrite this as sums or am I going to rewrite it as differences? All right, so a little early on y'all today, right? All right, y'all, so let me show you what we got. All those factors are being multiplied inside those parentheses. So since all those factors are being multiplied, we're going to use the product rule. So we're going to rewrite them as sums. And we're going to distribute our log D to all 3 factors. So y'all watch this. We'll get a log D of x to the 4th plus our log D of y to the 8th plus our log base D of z. Now, there is one more thing I got to do to this problem, and it involves that power rule because I got logs with exponents. So these 2 logs that have exponents, we're going to have to bring these logs down to the front, these exponents down to the front, and rewrite this as a product. So this is using the power rule. So anytime you got exponents, we got to bring them down. So that I get 4 times the log base D of x, plus bringing the 8 down, I get an 8 times the log D of y. And then the last one didn't have an exponent, so it stays the same, log D of z. So anytime we're simplifying, we got to bring those exponents down, okay? All right, y'all got any questions on these yet? All right, y'all. So I'm not seeing anything. So let's continue on. So let's up the level here. Let's do a log B of a P squared Q to the seventh over M to the fourth B to the eighth. So y'all, we got stuff being multiplied, and we got stuff being divided. So the trick on this one, if the factors are on top, they'll be sums. The factors on the bottom will be subtracted. It almost goes back to the quotient rule of exponents. It's always the top factors minus the bottom. Now I'm going to distribute my log B to all four of these. But y'all remember, any factors from the top are positive, any factors from the bottom are negative. So let me start distributing that log base B. So I got a log base B of P squared plus a log base B of Q to the seventh. So these two factors were on top, they're positive. So now I'm getting to the bottom factors, they're going to be subtracted. So log B M4, and then minus my log B of B to the eighth. So we've got it rewritten as our sums and differences, but now I got exponents. So let me tell you this. On three of these, I'm going to bring down those exponents to the front. But y'all, I'm not doing that on this one. Because remember, I gave y'all a property while ago of a base to a power, remember? That was the fourth one I gave you. Right here, the log of a base to a power. Well, if the base of the log matches the base raised to an exponent, it always equals the exponent. So y'all look here. I got that happening right here. I got a log base B of a B to the eighth. So this last term is going to equal nothing but the 8. So let's get to rewriting. Bringing that 2 down, I get 2 log B of P. Bringing that 7 down, I get 7 log B of Q. That's going to be minus, bring the 4 down, 4 log B M minus, remember this whole term turns out to be nothing but 8. Okay? Y'all, and that's because if you bring the 8 down, you get 8 times log B of B. Well, remember, log base B of B is 1. So this becomes 8 times 1, which is basically the 8, okay? You know, that's as far as I can go. I have no more exponents up there. Everything's brought out, okay? All right, so let's see. They're throwing one with ln at us. ln of 4 divided by 9 x to the ninth y. Now I will do this ln just like I did this log. Anything from the top will be positive. Any of these three factors from the bottom are going to be negative, okay? So let's start distributing our ln. So we get an ln of 4, which is positive, and then it's going to be minus ln of the 9 minus ln of x to the ninth minus ln of y. And y'all guess what? There is one more step in this. I've got an exponent on this third term here. So since I got an exponent on the third term, I need to bring the exponent down in front of that LX and write it as a product. So here comes my ln of 4 minus my ln 9 minus 9 times the ln of x minus ln of y. And y'all really, that's the thing you sort of got to watch out for. Am I simplified enough? Do I have exponents? And are my signs right, okay? Remember, factors on top are always positive. Factors on bottom are always negative, okay? All right, y'all, so this next one's going to be a doozy for us. And this one has a little bit more work to it. So here we go. Log base A. And then it's got big parentheses and a big radical. And this radical is a index of 4. So under here, I got an M20, N16 over A cubed and B to the 5th. So, y'all, the first thing I want to do is rewrite this big radical. So let me bring down that log base A. So I'm going to put everything that was under the radical in parentheses, my M20, N16 over A cubed B5. So y'all, here's a question for y'all. What exponent would I put out here to represent this fourth root? So being really close, but remember, radicals turn into fractional exponents. So this whole thing here, to write the exponent over, we would write it as a 1/4. Okay, y'all, so remember, radicals will turn into fractional exponents for us, okay? All right, now, our next trick, we need to distribute that 1/4 and multiply by every exponent in here. So bring down my log A. All right, y'all. So what is 20 times 1/4? That's going to give me a M. So really, what is a fourth of a 20? All right, so that's going to give me a 5 on that one. On my N, I got a fourth of 16. 16 times 1/4 will give me what? All right, so that's going to be a 4. Now, y'all, these exponents on bottom don't divide by 4, so just multiply 3 times 1/4. And just remember, when you multiply, treat the 3 like it's got a 1, and just multiply straight across. So 3 times 1/4 will give me A to the 3/4. And then on the B, 5 times 1/4 would give me B to the 5/4. All right, so I end up with an M5, N4 over an A to the 3/4, B to the 5/4. And y'all, guess what? We ain't even done the sums or differences yet. All we did was convert this thing out of this radical, and then we sort of distributed that exponent to end up with this. Now, we will start rewriting it. So these two factors on top are positive. These two factors on bottom are going to be negative. So I get a log base A, m to the fifth, plus log base A, n to the fourth. So they're both positive. Now I start subtracting log base A of A to the 3/4 minus my log base A of B to the 5/4. So y'all look at this. I will say this. Three of these I'm going to bring down exponents, and one of these I'm just going to write as a looks like a fraction on this one, right? So here, bring down to 5. Here, bring down to 4. But y'all look at here. You got a base that matches the base to an exponent. So this third term is going to be nothing but the exponent 3/4. And then on this last term, I'll bring down the exponent. So I get 5 times the log A m plus bringing that 4 down, I get a 4 log A n minus, no, we said this whole thing here equals 3/4. And then minus, bring down to 5/4. You get a 5/4 log A of B. Hey, y'all, so that's the trick. Get that radical converted over into a fractional exponent and then start distributing it in here. And at this point, you start rewriting it as sums and differences. But you'll always be aware of these type of things. A to the 3/4. Okay? All right, y'all. Any questions on that one? So that's sort of tricky. I ain't saying nothing, y'all. So let's move on. Number 11. Oh, no, these are new examples, y'all. So let me rewrite this. This example wants me to express as a single logarithm. All right, this is another big thing that you got to be able to do tomorrow when we do the equations, okay? Now, when they say rewrite as a single logarithm, what they're doing, they're going from this side to this. So if you got two things added, we'll write them as a product. If we got two things being subtracted, we'll write them as a quotient, okay? So we're sort of going from 2 logs into 1. This is something you gotta do tomorrow for sure. So my number 11 has a log base t of 3 plus a log base t of 79. Now, what's enabling me to write them as single logs is they gotta have the same bases, okay? So both of these are a log base t. So I can rewrite this as a log base t of 3 times 79. All right, y'all. So all we got to do now is multiply that 3 times 79 and see what we get. So I'm going to end up with a log base t. Let's see. 3 times 79 ended up being 237. So when you're rewriting it as a single log, they sort of want me to multiply them out if I got numbers, okay? All right, y'all. So adding turned into a product. Let's do one with subtraction. Log of 10,000 minus the log of 100. So they're being subtracted. Since they're being subtracted, I rewrite it as a quotient. The positive factor will be on top. The factor being subtracted will be to the bottom. So bring out your log. On top, we have 10,000 over 100. All right, so let's figure out what is 10,000 divided by 100. That'll give me a log of 100. So y'all, that's the first answer. But then Math Lab says, well, hey, this simplifies to what? So y'all, what is this? Log of 100. Y'all got a button right on that calculator that'll solve that. But remember, there's not a base here, so the base is automatically a 10. So what exponent would I raise 10 to equal 100? So this is the only one that sort of makes you simplify it a little further. And being you're perfect, that is a 2. So on your number 12, when you're dealing with the 10,000s and all that, you'll get the first answer, and then it'll also say this simplifies to whatever, okay? All right, y'all, next they say simplify the expression. All right, so 13 has the ln of x squared plus 16x plus 60 minus the ln of x plus 10. So y'all, the first thing I want to do is rewrite this as a single logarithm. And remember, this was being subtracted, so it's going to look sort of like a quotient here. So bring out that ln. So the positive factor goes to the top, x squared plus 16x plus 60 over x plus 10. Since it's being subtracted, it's going to the bottom, x plus 10. Now, y'all, to simplify this one, we're going to have to factor the top of it and cancel out any common factors they have. So the trick on this problem is going to be factoring that top. Now the bottom's just an x plus 10, so nothing we can do to that. So the bottom's going to stay at x plus 10. All right, y'all, so let's factor this top. X squared is an x and an x. This last number's positive. Anytime the last number's positive, both of these factors will be same sign as the middle. So both of these factors are going to be positive. So y'all, what I need are factors of 60 that'll give me 16 when I add them. And y'all, if you want a clue, look what one of the factors is on the bottom. If that thing's going to cancel anything out, good job, Olivia. One of them factors better be a 10, right? So Olivia said, let's make that a 6 and a 10. So now that you got the factor top, you can see that we have a common factor. So we need to cancel out that common factor. And our final answer will be a ln of x plus 6. Now on this one, since the ln affects this whole factor, you got to keep this one in parentheses, okay? So got to keep the parentheses on this problem. Because if you don't do the parentheses, it'll be like the ln of x plus 6. The ln wouldn't affect the 6 unless it's in those parentheses, okay? All right, y'all. So The other one is similar to this one, okay? But this one's dealing with logs. They got a log x squared plus 10x plus 21 minus a log of x squared minus 9. So y'all, it's being subtracted, so I'm going to rewrite it as a single log like I did over here. So I'll bring out that log. On top will be the x squared plus 10x plus 21. On bottom, the x squared minus 9. So y'all, since you got an x squared on top and an x squared on bottom, both of these are going to need to be factored. And they will both end up in parentheses, okay? So y'all, let's play at the top. X squared, that's an x and an x. Last one's positive, so both of these will be positive like the middle. So y'all, can y'all find me factors of 21 that'll add to get a 10? So that'd be a 3 and a 7. Good job. Now y'all, look here. This bottom, this is what we call perfect squares. Now there's not an x in the middle. So since there's not an x in the middle, it's like a 0x, okay? So this is really x squared plus 0x minus 9. But y'all, here we go. X squared is an x and an x. The last number's negative. Anytime the last number's negative, you got a positive factor and a negative. All right, y'all, so what I need on this one, I want factors of 9 that'll subtract and give me 0. So what factors of 9 will subtract and give me 0? All right, Ben, 3 and 3, perfect. So anytime you got these perfect squares, they're going to be factored into conjugate pairs like this, okay? So if you got an x squared minus 16, you would have x plus 4, x minus 4. X squared minus 25, x plus 5, x minus 5, and so on, okay? Hey, but y'all, look here. We got something to cancel. These x plus 3's are canceling out. So on this one, since you got a single fraction left, you do not need the parentheses, because this would be an x plus 7 over x minus 3. So since we still got one fraction, we don't need parentheses. But y'all, this number 13, you got to keep the parentheses, okay? And it just matters, like, is everything being affected by that LN or not, okay? All right, y'all, so any questions on those? So y'all, if y'all don't have no questions, we're going to knock out our support real quick. And the support had 5 questions going over exponent rules. So this would be 9.5 support. So let me write my exponent rules over here. So we got a product rule. Product rule says x to the a times x to the b equals x to the a plus b. Similar to the product rule of logarithms. When you got a product, we added the exponents, okay? We got a quotient rule. And it says x to the a divided by x to the b equals x to the a minus b. So it's the top one minus the bottom one, just like we did on our logarithms when we were rewriting them. So the power rule we got, x to the m raised to the n equals x to the m times n. So this is like an exponent raised to an exponent. You multiplied those exponents. So that's what we did in the power rule of logs. We wrote them as a product, okay? Now we also got what we call the negative exponent. Because y'all, we don't like keeping negative exponents in our answers. So if we got something like this, x to the negative m, to make an exponent positive, you pull it under 1. And this gives me x to the m. So remember I said yesterday, negative exponents were sort of shorthand for fractions, okay? Now, also this rule says, if I got 1 over x to the negative m, so if your negative exponent is on the bottom, you move it to the top and make it positive. So moving stuff down under 1 or back up changes the signs of those exponents, okay? And y'all, the last one was the zero exponent. They don't hit us with this, but I wanted to keep this fresh with y'all. Anything to an exponent of 0 equals 1, okay? So these are your exponent rules. So let's see what they're doing on these examples. And y'all, these are going to say simplify. But write with positive exponents. Okay, so if you get negative exponents, you're going to do something like this and get them things to be positive, okay? All right, y'all, so right off the bat, x to the 5th times x to the negative 8. Well, you're multiplying. We said the product rule, we're going to add exponents. So we're going to have x to the 5 plus a negative 8. Well, y'all, 5 and negative 8 is going to give me a negative 3. But y'all, they told me to write with positive exponents. So here, x to the negative m is similar to my x to the negative 3. So to make that exponent positive, I'm going to bring everything down under a 1. And I get 1 over x to the 3rd. Okay, y'all, so hopefully this is bringing back memories from transitional algebra or intermediate algebra, whatever you've taken. But you got to make the exponents positive for these final answers. All right, y'all, look here. Y to the negative 4th times y to the 9th times y to the 8th. All right, y'all, so you're multiplying, so you're going to add all these exponents. So that's really going to give you y to the negative 4 plus 9 plus 8. So y'all, let's see. What are y'all getting on that? What's that? Negative 4 plus 9 is what? 5. And then 5 plus 8 is what? 13. So I get y to the 13th. And y'all, guess what? That exponent is positive. So I don't do nothing else to it. Final answer. So you're only going to change the sign if they're negative, okay? All right, y'all. 9x squared squared times 2x to the fourth. Whoops, hang on, y'all. That 4 was outside the parentheses. So let me rewrite this one. 9x squared squared times 2x, and then the 4 was on the outside. So, y'all, you cannot multiply until you take care of exponents first. You got these two exponents out here. Now, this exponent affects both the 9 and the x squared. This exponent of 4 affects both the 2 and the x. So these are like exponents raised to exponents. So we're using the power rule. We're going to multiply them on these variables. But y'all here, you got 9 being squared. So that's 9 times 9, which is 81. On the x, 2 times 2 is 4. So that gives me an x to the fourth. That'll be multiplied by what I get over here. Well, y'all got 2 to the fourth. So that's 2 times 2 times 2 times 2, which is 16. And then on my x, y'all remember there's not an exponent by the x, so it's automatically a 1. And 1 times 4 is 4. So we've taken care of these exponents. Now we got stuff being multiplied. Woo! So one of y'all figure this out. 81 times 16. So the numbers multiply. So what are we getting when we do an 81 times 16? 1296. And then y'all, the x4 times the x4, I'm using my product rule. And 4 plus 4 gives me an x to the 8th. Okay? Remember, variables times variables, you're going to add the exponents. Right here, you had an exponent raised to an exponent. So that's why we multiplied those, okay? All right, y'all try this. B7 over B to the negative 2. So here's my quotient rule. It's the top minus the bottom. So these B's, this will be 7 minus negative 2. So if the bottom exponent is negative, when you subtract it, it will become a positive here. So you really have B7 plus 2. Y'all, that ends up what? Being a B to the ninth. Okay, so if you got negative exponents on the bottom, when you subtract that negative, it becomes a positive. All right, y'all, one more. And this is going back to that power rule. 4x to the 8th, y to the 6th squared. So basically, we're just going to distribute this outside exponent to all three of these factors. So first of all, 4 squared would be 4 times 4, which is 16. So y'all, what's the exponent going to be on my x? Ooh, I see what you did. You squared that 8. Remember, Olivia, your power rule, multiply those exponents. So Ben got it. 8 times 2 was 16. Now how about that y? So Olivia only squared a number. On the exponents, you sort of got to follow these rules, okay? All right, y'all, how about my y? And that'll be a 12. Good job. Okay. And y'all, that's why they're throwing numbers at you because they're trying to confuse you. Although you are squaring to 4, when you square an exponent, remember just multiply them and be done. All righty, y'all. So, any questions over today? So, I'm going to keep it sort of light today because um, I want y'all to get good at these properties because tomorrow we're going to solve equations and you got to use these properties to solve those equations, okay? Plus, we got to do the stuff like we did yesterday, being able to convert from logarithmic to exponential and vice versa. So all that was doing was getting us ready for tomorrow, okay?